Hello everyone, this is part C of name reaction series and today we are going to cover name reactions starting with alphabet C. So today in this video we are going to cover following name reactions, that is CANNIZZARO reaction, CARBYLAMINE reaction, CLEMMENSEN reduction reaction and coupling reaction. So our first reaction is CANNIZZARO reaction. It is a self-oxidation and reduction process of an aldehyde containing no alpha hydrogen atom in the presence of concentrated solution of sodium hydroxide or potassium hydroxide. This reaction is shown by aldehydes which do not contain any alpha hydrogen atoms like formaldehyde, benzaldehyde, etc. So in this reaction, we have to take two aldehyde molecules. One aldehyde molecule will get oxidized into carboxylic acid salt and one aldehyde molecule will get reduced into alcohol. So in CANNIZZARO reaction, we have to take two molecules of same aldehyde without any alpha hydrogen atom. So in first case, we have taken two molecules of formaldehyde, that is SCHO. We have reacted SCHO two molecules with concentrated NaOH or 50% NaOH solution. One molecule of SCHO is oxidized into carboxylic acid salt with same number of carbon atoms, that is SCOONA, which is sodium formate. The second molecule of SCHO is reduced into alcohol having same number of carbon atom, that is CH3OH methanol. In our second example, we have taken two molecules of benzaldehyde. One molecule of benzaldehyde is oxidized into sodium benzoate, that is C6H5COONA, and the second molecule of benzaldehyde is reduced into benzyl alcohol, that is C6H5CH2OH. So our next reaction is CARBYLAMINE reaction or CARBYLAMINE test, which is also called as isocyanide test. In this reaction, we have to take either aliphatic or aromatic primary amine, which is heated in the presence of chloroform and alcoholic solution of potassium hydroxide, forming isocyanide, which is having very offensive smell. The reaction is only given by primary amines, that is why it is used as a test to distinguish between primary amine, secondary amine and tertiary amines. In this reaction, we have to take primary amine, which is RNH2. R is either aliphatic carbon chain or aromatic part. This RNH2 is reacted with chloroform, CaCl3 and alcoholic solution of KOH. This reaction mixture is heated and after reaction, RNC, which is alkyl isocyanide or carbylamine part, is obtained as the main product and 3 moles of KCl and 3 moles of water is obtained as side product. So taking proper example of CARBYLAMINE reaction, in the second part, we are going to take ethanamine or ethylamine, which is our primary amine. Its formula is CH3CH2NH2. We are going to react this with chloroform, which is CHCl3 and alcoholic solution of potassium hydroxide, which is KOH. We are going to heat up this reaction mixture forming CH3CH2NC, 3 moles of KCl and 3 moles of water. In this reaction, 3 potassium will combine with 3 Cl part from chloroform forming 3 moles of KCl. 2 hydrogen atoms from ethanamine, 1 hydrogen atom of chloroform will combine with 3 OH part, forming 3 moles of H2O. Now we are left with CH3CH2N part of ethanamine, which will combine with C, that is carbon part of chloroform, forming ethyl carbylamine, which is CH3CH2NC. If the compound contains NC part along with carbon atom chain, then it will be a carbylamine or isocyanide, but if it contains carbon part attached to CN, then it will be cyanide. So in our third example, we are going to take aniline, which is benzene ring having NH2, which is also our primary amine. We are going to react this aromatic primary amine with chloroform and 3 moles of alcoholic KOH solution. Upon heating, it will form phenyl carbylamine or phenyl isocyanide. The side products will be 3 moles of KCl and 3 moles of water. In this reaction also, 3 potassium from KOH will react with 3 Cl part from chloroform. It will give you 3 moles of KCl. 2 hydrogen atoms from aniline, 1 hydrogen atom from chloroform and 3 OH part from alcoholic potassium hydroxide will combine giving 3 moles of H2O. Now we are left with aniline having benzene ring N and C part of chloroform. These will combine together forming phenyl carbylamine, that is benzene ring having NC. So our next reaction is Clemmensen reduction reaction. In this reaction, we have to take either aldehyde or ketone reacting with zinc-amalgam, which is mixture of zinc and mercury and concentrated HCl. After the reaction of zinc-mercury mixture with concentrated HCl, there will be production of 4 nascent hydrogen atoms. Those 4 nascent hydrogen atoms will combine with either aldehyde or ketone molecule, giving corresponding alkane. The side product will be water molecule. As we can see in our first example, we have taken acetaldehyde or ethanol, that is CH3CHO, reacting with 4 nascent hydrogen, and the product form is ethane, CH3CH3, and the side product is water. In this reaction, the number of carbon atom of aldehyde or ketone and the corresponding alkane formed will remain same. So for learning this reaction, you have to make structural formula. Upon reaction with 4 nascent hydrogen, there will be dissociation of bond between carbon and double bond oxygen. After the dissociation of the bond, for the satisfaction of the 2 valencies, oxygen will combine with 2 hydrogen atoms forming H2O. Now, for satisfying all the 4 valencies, the carbon atom will combine with 2 hydrogen atoms forming CH3CH3. In our second example, we are going to react propane 2-one, which is commonly known as acetone, with 4 nascent hydrogen atoms. In this reduction process also, there will be dissociation of bond between carbon and oxygen atom. 2 hydrogen will combine with oxygen atom forming H2O, and leftover 2 hydrogen atoms will combine with the carbon atom for satisfying its valencies forming CH3, CH2, CH3. So number of carbon atoms in propane 2-one and propanone will remain same. In the third example, we are going to take aromatic ketone, which is 1-phenylethanone which is commonly called as acetophenone. This will be reacted with 4 nascent hydrogen atoms produced by reaction of zinc-amalgam with concentrated HCl. In this case also, there will be dissociation of bond between carbon and oxygen. Oxygen will combine with 2 hydrogen atoms forming H2O, and leftover 2 hydrogen atoms will combine with carbon forming benzene ring CH2CH3, that is ethyl benzene. So our fourth named reaction is coupling reaction. The reaction of diazonium salts like benzene ring having N2Cl with phenols and aromatic amines to form azo compounds in the presence of ice-cold basic or acidic solution is known as coupling reaction. This reaction involves the coupling of a diazonium salt at the para position of phenol or an aromatic amine, resulting in the formation of a bright colored azo dye. When phenol is treated with weakly alkaline solution of benzene diazonium chloride at 273 to 278 Kelvin temperature, then para-hydroxy azobenzene is obtained, which is orange in color. But when aniline is treated with acidic solution of benzene diazonium chloride at 303 to 313 Kelvin temperature, then para-amino azobenzene is obtained, which is a yellow colored azo dye. Thank you for watching this video. Please like the video, share it and subscribe to my channel. Thank you.